For the second application, we're going to look at how a computer evaluates mathematical expressions. So if you've ever wondered how your calculator or how MATLAB or any other computer program evaluates expressions and keeps track of order of operations and all sorts of things like that, we're going to see sort of the introduction to how this works. So we have an expression here, 3 times 7 minus 6 divided by 2 plus 9. Now you should know, of course, the order of operations, that multiplication and division come before addition and subtraction. We haven't added parentheses to this or anything, but we'll worry about that later on. Now if you look closely at this, you'll notice that there are 4 operations happening. There's a multiplication, a subtraction, a division, and addition. And each of those operations is a binary operation, meaning it's acting on 2 values. So the 3 times 7, for instance, there's a binary operation that takes 3 and 7 and multiplies them. Same thing with the 6 and the 2 joined by division. And then after you've done that, you would take the value in each of those circles and combine them with subtraction, and then the result with addition, and so on. So each of these operations is a binary operation, which means that we're going to use a binary tree again to describe this. So it's the same kind of idea that we saw with binary search trees. We're still going to use a binary tree to evaluate this. So we start by breaking it down by operation. So we're going to take an operation and use it to split the expression into 2 pieces. Now, without going into too much detail here, because of the order of operations, we're going to start with the minus sign and not the multiplication, because we want the, well, when we eventually evaluate this, we're going to work from the bottom of the tree up. And so we want the operations with a earlier priority, a higher priority, to come further down the list. So we want multiplication to end up further down the list. So don't worry too much about it for now, but we're going to break it down by starting with the subtraction. And what the subtraction uses as its 2 arguments is the 3 times 7 and the 6 divided by 2 plus 9. So those 2 pieces are what get combined with subtraction. So all of this and all this. And then we can keep doing this, and at each point we can split with a given operation. So if we keep breaking it down, subtraction splits up, and then if we take a look at that left side, we have multiplication, and then that multiplication takes the 3 and the 7 and multiplies them. And then on the right hand side, where we have 6 divided by 2 plus 9, where again we have 2 operations here. We're going to take the one with the lower priority first, the addition, and that's going to split into 2 pieces. One of them is just 9, so that's done. The other one is 6 divided by 2, so we're going to have division that splits up the 6 and the 2. Notice that division order matters unlike the others, but that's more than we're going to worry about right now. So that's how you would break this down, and then you construct this expression tree. And this tree is something that the computer can evaluate, because what it'll do is it will start sort of collapsing things from the bottom up. Now we can, the way it's usually done is to write this in what's called reverse Polish notation, or sometimes called postfix notation. If you haven't heard this term postfix notation, what we do here is, by contrast, called infix notation, which means that the operations are written in the middle of all the values. Postfix notation looks a little weird at first, but essentially what you do is you write the values and then the operation at the end. So let me give you a few examples. If I wrote something like 3, 5 plus, you would read that and you would say, I'm going to take 3 and 5 and combine them with addition. So that would be the same as 3 plus 5. If I wrote something like 3, 5, plus 9 minus, you would read through it, and every time you come to an operation, you would use that operation on the values you've captured so far. So you would hit 3 and 5, and then as soon as you hit addition, you would add them together and get 8. So 8 is your current number. Then you'd have 9, and then subtraction. So you would take 8 and 9 and combine them with subtraction. You'd have 8 minus 9, which would be -1. And then, just to give you a more complicated example, if you had something like 2, 1, 5, 6, plus, times, minus, you would read the 2, the 1, then you would read 5 and 6, and plus. And so you'd take the two most recent values with the plus, so you'd get 11. And then you would have times, so you go back and look at your two most recent values, the 11 times the 1, so you'd have 11. So all of this together would be 11. And then when you hit the minus, you would go back and read the two most recent values, the 11 and the 2, so you'd have 2 minus 11, which is -9. So once you get the hang of this, it's not too bad, but basically at each stage, whenever you hit an operation, you pick up the two most recent values, combine them with that operation, and then add that at that location in the list. So for our example, 3 times 7 minus 6 divided by 2 plus 9, we would write 3, 7 times, then 6, 2 divided by, then 9, then plus, then minus. Now let me show you how I did that. Basically what you do is you go, starting at the bottom level of this list, you take the 3, the 7, and you write them down in that order, and then you step up and you select the operation that's right above that, the times. And then you do the same thing on the other side of the list. So we start with 6, 2 divided by, and then we compare to the other side there. So basically at each level you're taking each value and its matched pair. So 6 and 2 go together, so we select them, and then when we select divided by, we select the one that goes with that as well, 9. So we have 3 7 times, that's one side, and then 6 and 2 go together, divided by and 9 go together, and then when you step up, the times and the plus go together, and then you have minus at the very top. So it can be hard to see the first time you do this, but the order of operations determines where everything lands in this tree, and then you can use that tree to build the reverse Polish notation. There are more details to this, and if you're interested, you can dig into this more and figure out how this algorithm works to generate this with a computer, but you can do it by hand more easily. So again, you would start evaluating this, you would read the 3 and the 7, and then multiply them, and then take that answer and replace all of this with 21. And then you would have 6 and 2. Once you hit divided by, you would evaluate it with 6 and 2, so you get 3. So you'd have a 21 here and a 3 here. And then when you keep going, you hit 9 and then plus. So the plus would go back and pick up the 9 and the 3 and add those together. And then the minus would go back and pick up the 21 and the 12 that you have there. So anyway, that's the basics of how a computer keeps track of order of operations and evaluates an expression like this. It builds an expression tree, and then it evaluates it in reverse Polish notation. Let me show you another example. It's more complicated, but just to sort of round this out, how this works. Again, if you want to try, you can pause the video and try doing this one on your own. It's a little more complicated, but it's the same principle. If you look through this, thinking about order of operations, we've got parentheses here and multiplication, we've got parentheses. So the last operation in terms of priority is this subtraction, meaning that's going to be the one at the top of our tree. So you want to start at the top of the tree with the lowest priority operation. And then when we split this up, let's see what we have. On the right-hand side, let's take that because it's a little bit easier. Once we are looking at that alone, we don't need the parentheses anymore. So we have 2 plus 1 plus 1. So the lowest priority thing, the last operation you would do, would be this plus. So we'll start with that. And then one side of that has a 2, and the other side of it is 1 plus 1. So that's another plus operation with 1 and 1. So that's the right-hand side of the whole expression. The left-hand side looks more complicated, but at first it's just this bracketed piece times 3. So we'll have multiplication here. One side of it, I'll do it this way. One side will just be 3, and then the other side will come down here, and we'll see what else we have. So zooming in one more level, we get to here, and it's 15 divided by something in parentheses. So it's going to be division. One side is just going to be 15, and the other side is going to be this other whole expression. Zooming in even further, it's 7 minus 1 plus 1. So we have subtraction with 7, and then on the other side we have addition with 1 and 1. So again, we've got our whole expression broken down into this binary search tree. So to do this, the way I've written this is a little bit different because I have the 3 on the left side here and everything else on the right side, but it works out the same because multiplication can be reversed like that. So to read this, we're going to do something like this. We're going to start at the far left with this 3. So we'll have 3, and then basically we're going to fill in everything to the right of that before we step up and include the multiplication. And then before we step up and include the subtraction, we're going to include everything over here. That's kind of the idea, is you start on the left, and then before you can step up, you need to include everything to the right of it. So the brackets are not going to show up in our final expression, but I'm just including that to kind of show you where everything's going to go. So in the brackets, we step forward and we have, looking at this piece, the leftmost is the 15, so we're going to have 15. And then before we can include the division, we'll include that at the end, we have to include this other remainder down here. So we look at that, the furthest left piece is the 7. And then we would include the minus, but before we do, we have to include all of this down here. So going down, we have on the left a 1, and then a 1, and then a plus. So that's roughly how it works, is you start at the leftmost piece here, and then before you can go up, you have to first deal with all this. And so you keep traveling down the tree until you cover everything. And then as you go, you put the operation that's above it at the end, and then everything to the right of it in between. So it's hard to see this the first time, but after a little bit of practice, you should be okay. So once we've done that, we would like to step up and do the minus, but first we have to include all of the stuff to the right over here. So again, looking at that smaller piece, the leftmost thing is the 2, and then we would include the plus, but first we have to include this stuff. So then we look at, there's a 1 and a 1 and another plus. So make it take a couple tries to go through and practice doing this. But it basically, again, comes down to start with the leftmost piece, and then before you include the operation above it, include everything to your right and keep nesting that in. So it's kind of this recursive model to it that takes a little bit of getting used to. But there's the reverse Polish notation. And to us, this looks less familiar, but it's easy to write a program that can take care of this. Now, this isn't something you strictly need to know, but just in case you're curious, the way this works is there's what's called a stack. And if you've done a fair amount of programming, you might have run across something called a stack. The idea of a stack, it's like a stack of plates. If you start stacking them, when you go to take something off the stack, you pick off the top item. So if you add something to the stack, it goes on the top. If you remove something, it comes off the top. And so that's one way of keeping track of operations like this. So what the stack for this would look like is it would start reading through this list and start adding these to the stack as it goes. So it would start and it would add a 3 first, then it would add a 15 on top of that, then a 7, then a 1, then a 1, and then every time it hits an operation, it pops the 2 top values off the stack, and it would take these 2 and combine them with addition. And so then the stack would look like this. You have 3, 15, and 7, and 2. So every time it runs into an operation, it takes the current stack, lifts off the top 2 items, combines them, and adds that result back onto the stack. So then at that point, it's going to read the next value, which is a minus. So it's going to pick off these 2 values with subtraction. And then you'll have 3 and 15 and 5. Then it's going to keep reading and it's going to get to division. So it's going to read off the top 2 values on the stack, divide those and get 3. And then it's going to keep reading and it's going to get multiplication. So it's going to grab those 2 values and multiply them. So now the stack just has a 9 in it. It's going to need a little more space. Then if it keeps reading, it gets a 2, then a 1, then a 1. Then it hits addition again, so it grabs these 2 and adds them. Then it hits addition again, so it grabs these 2 and adds them. And then it hits subtraction, so it grabs these 2 and subtracts to get 5. And then it's done. It reaches the end of the list, so it knows that it's done carrying out these operations, and it has the final answer of 5. So again, for our purposes, we can read through an expression like this and we can kind of see it as a whole, and we can do things like recognize brackets and recognize parentheses and recognize order of operations. But you need to have a consistent, relatively simple process that you can tell the computer to do so that it can read through one character at a time and keep track of what operations to do. And the way it does it is by building this expression tree and then writing things in reverse Polish notation or postfix notation and then carrying out this operation with the stack. So that's roughly what's happening in your calculator, or if you use any sort of computer program to evaluate mathematical expressions, that's what it's doing to do so.